At this point, I'd like to summarize where we stand in this section. Each one of the points on this page you're looking at are really important, and I'll make sure a PDF is posted for this page in Canvas so you can refer back to it all in one viewing. The values of trig functions for angles in standard position, reference angles, and coterminal angles. So the first point, for any angle theta, if xy is the point of intersection of the terminal side of theta in standard position with a circle of radius r centered at 0, 0, cosine theta is x over r, sine theta is y over r, tan theta is y over x. In fact, we've been talking about this. We already have we set up a yellow card already with this information. I'm putting cosine first just because we want to remember cosine is always attached to the x coordinate, sine to the y coordinate. Second point, we will often use reference angles to help us compute the values of trig functions by hand for angles with terminal sides in quadrants 2, 3, and 4. This is the whole point of why we have studied reference angles. And so the next point, a trig function value for any angle theta is always going to be either plus or minus, one or the other, the trig function value of the reference angle, the corresponding reference angle. The plus or minus sign is determined by the quadrant that the terminal side happens to be in. And we'll start working on this in the next few exercises. So I made another yellow card here that I just want to show you. It kind of simplifies. It's the same statement so for any angle theta, sine theta is either plus or minus sine of the reference angle for theta. Choice of plus or minus depends on the quadrant. And the same is true for all the other trig functions. For any reference angle, all trig function values are positive because reference angles are always acute angles. Reference angles are always between 0 and 90 degrees. And coterminal angles have equal trig function values. So if you just happen to know that two angles are coterminal, then, and you know the trig function values for one, you can use those same values for the other. Now let's go ahead and start an exercise. And here we go. So here's sort of the real thing now that we've been working up to. I feel like this is a really important exercise. And so find the exact values of the sine, cosine, and tangent of 3 pi over 4 radians. Okay. Now we're also going to use information that we've already memorized on another card. Remember, we have our special angles whose trig function values we've memorized. We're going to be able to use this information and extend it to some of these other angles now. Now the first thing I want to try to do is picture 3 pi over 4 radians. I know that pi over 4 is 45 degrees, right? And so 3 pi over 4, just think of it as 3 times pi over 4. We can look at those multiples of 45. So it's 1 times pi over 4, 2 times pi over 4, 3 times pi over 4. You could convert to degrees, but if you think in terms of radians, we can get right to this picture. Here's 3 pi over 4. And so what we want to notice is that the terminal side is in quadrant 2. That's going to help us decide whether our trig function values are positive or negative. We need a reference angle. The reference angle is this angle right here. Now, this shouldn't be too hard to see because we're dealing with multiples of pi over 4. 1, 2, 3 pi over 4, 4 pi over 4 would be equal to 180 degrees. So we need one more pi over 4. This guy is going to be pi over 4, the reference angle. If you want to calculate it, you could figure it out by taking pi minus 3 pi over 4. If you don't just see that, you could take pi as like 180 degrees minus 3 pi over 4. That's 4 pi over 4 with a common denominator minus 3 pi over 4. That's another way to get this reference angle of pi over 4. So we have reference angle of pi over 4. Now, this is just what we need to carry out our calculations. Now, the sine of 3 pi over 4 is going to be related to the sine of pi over 4. It's going to be plus or minus the sine of the reference angle, which is pi over 4. Now, we have to choose one. We don't really write plus or minus for our final answer. We have to choose whether it's positive or negative. Because we're in quadrant 2, we know points in quadrant 2 have x coordinates that are negative, y coordinates that are positive, and the x coordinate always tells us about cosine. The y coordinate is always going to tell us about sine. So because the y coordinates are positive in quadrant 2, we know the sign is positive. So we know to choose a plus sign. And the sine of pi over 4, we have memorized. We already have it on our card. Sine of pi over 4 is square root of 2 over 2. So the sine of 3 pi over 4 is also square root of 2 over 2. Now let's do cosine of 3 pi over 4. That's going to be plus or minus cosine of the reference angle, pi over 4. And we got to choose. Now, I'm trying to think, maybe up here for sine, above that plus sign, I should have wrote quadrant 2, because that's where that information came into play. Because we're in quadrant 2 and x coordinates are negative, sorry, coming down to my picture, we know cosine will be negative. So here, because of quadrant 2, we take a minus the cosine of pi over 4, which is minus cosine of pi over 4. We have memorized. It's on our card. Is square root of 2 over 2. So we get minus square root of 2 over 2. So there's the cosine of 3 pi over 4. So it's very similar to sine and cosine of pi over 4, but we got to figure out when they're negative. And the negative is decided by the quadrant, whether x or y are negative in that quadrant. Now, tangent of 3 pi over 4 you can, I think the easiest way here is to just take sine of 3 pi over 4 over cosine of 3 pi over 4. You can always take sine over cosine to calculate tangent. The sine of 3 pi over 4 was square root of 2 over 2, positive. The cosine of 3 pi over 4 is negative square root of 2 over 2. So what we got to realize here is we are dividing a number by itself. We're going to get 1 when we divide, but a positive divided by a negative is negative. So we get a negative 1 for the tangent. So again, what's new here is we're trying to figure out when do these quantities come out to be negative. So there we got the sine, cosine, tangent of 3 pi over 4. And I'm actually going to, maybe I'll try to get the whole, well, I can't get the whole thing in there, but there we go.